Hello guys, and welcome to this tutorial. In this video, we'll be looking at the various subsets under the various fundamental data types and why we have those data types, the major reason we have those data types. And we will be performing operations on strings like appending, like insertion, and all of these. We'll get to know more about that in a bit. Now, we have various subsets under the various fundamental data types. So for example, under character types, we have character, which is the normal one, and we have character 16T and character 32T. And for integers, we have signed and unsigned integers. And for signed, we have signed character, signed short integer, signed integers, and all of these. Now, why do we have all of these? The major reason is to allow us the freedom to explicitly state and tell the computer that for this particular variable, for this particular value, I want this amount of space to be created for it. Now, you would better understand it with this scenario. Let's say you spend a lot of resources to build a house, right? Now, a big house, and at the end, you have few people living in it. That is not an efficient use of resources. Let's say a bigger house should correspond to a reasonably large amount of people to correspond to the size of the house. So in this case, when you create a variable in C++, the normal one that we always use, for example, in integers is the signed int. Yeah, when you just call the int, you mean a signed int, and a space of at least 16 bits it's allocated to it. Now, when you do that, you create a particular space on the disk for that particular variable. But the case that you have allocated 16 bits for that variable, but then you will not be using all of the 16 bits, right? So that would not be an efficient use of space. So for this reason, C++ allows us the freedom to explicitly state that this particular variable is going to store 8 bits, so just create this amount of space for it. And this particular variable is going to be big, so create this space for it, right? So that's the major reason we have these subsets under the various fundamental data types to allow us the freedom to explicitly state the storage capacity we want for our variables, and then that would improve the memory usage and then the disk usage so that the overall efficiency of the program will be smooth. Yeah, so that's basically the reason. And throughout this tutorial, we'll not be paying much attention to these details unless, of course, probably a software engineer or someone who is so much into efficiency and space, right? So that's it for the theory, and let's just get to see what we really mean, right? So the first type under character types is char, and that one is exactly 1 byte in size, and 1 byte corresponds to 8 bits, right? And the second type is character 16T, and this one is when you use this particular type, you want to tell the computer that create a space not smaller than 8 bits but at least 16 bits. When you use this keyword character 32T, you're telling the computer that, hey, this particular variable I am creating needs at least 32 bits, right? And so on and so forth. So let's go ahead and then illustrate with an example. So let's say that I am creating a variable, and the variable is going to store character, right? And then I want to tell the computer that create 8-bit storage space for this particular variable. So how do I do it? You start by declaring your character data type, and then I want to store in L1. Yeah, that's my first character, letter 1. Let's just call it letter 1. And it's going to be equal to, let's keep hello in there. And you know characters are put in single quotation marks, right? So let's just put in hello in there. Or let's just put in H in there for now with a semicolon, right? So this is my character I just created, and we know this procedure already. Now let me go ahead to print out this character, right? Let me print out this character, ENDL semicolon, and then I run this by using Shift B. Right, so we have an H over there. I press indicate to continue. Right, So now I want to get the size of this particular variable. So what I can do is I can print cout size of, and then put whatever size that I'm looking for in the parentheses. So in this case, we are looking for the size of L1. And then we add these less than signs and E and DL, right? So we go ahead and run this, Shift Enter, Shift B, and then we have the size as 1. And 1 here is in bytes, and 1 byte correspond to 8 bits, right? So we are good to go. So the character over here has 8, 1 byte, that's 8 bits. So what we just did over here, anytime you use this keyword character, you are telling the computer that this particular variable, this particular character that I am creating, I want you to create a storage space of 8 bits, a storage space of 1 byte for it, because it's not big. Create a smaller room for it. So that's what basically this line means, right? So let's go ahead and then declare a second character using character 16, right? So when you use this keyword, you're telling the computer that this particular person, this particular variable is bigger than character. So create a larger room for it. That's what basically it means. Yeah. So we want to store this as L2, and we are equating it to, we are assigning it to, let's say, the same age. Let's keep it the same age, right? So we go ahead and then we print L2 and then size of L2. So we run this, Shift B. Sorry, I should put a semicolon over there. Shift B. Oops, I used a double quotation, right? Age. I hope you're good to go now. So Shift B. Right, so now we have, the first thing we wanted was we wanted to print out L2, and we stored an H in there. Now you can see that 72 was returned. That was not what we put in there, which we were expecting an H, just like the character returned the first time. But then the size of L2 is 2, and 2 here means 2 bytes, and 2 times 8 is 16, right? So over here it's 16. The first time character was 1. This one is 2. That means a bigger room was created for the same variable, right? So now why did it return 72? 72 is the ASCII value for it. And so we'll just look up what that means. And the ASCII values, it stands for American Standard Code for Information Interchange. So this is the format in which information is stored in the computer. It's not stored as letters, it's not stored as symbols, it's stored in binary format, in numbers, zeros and ones. And so in this case, when we look up the ASCII value of capital H, which is over here, we have 72 over here. So as you can see over here, yeah, so when the cursor is, this is the AI, it's 72, right? So it returned the ASCII value for that, and I don't know why it returned that value instead of H itself. In any way, let's go ahead and then create a third variable to illustrate what to illustrate the concept of this video. So I'll create a third character, and we are going to use 32. That means we want a bigger room, and we want to call this variable L3, and we are assigning it to the same age, right? We're assigning it to the same age. So basically, we have the same variable, it's of the same size, but then we are changing the rooms, right? So this is just to illustrate the concept of efficiency. If you use character 32T, you are telling the computer to create a bigger room for this variable when you could have used this. I hope you get the concept. So this is just to allow for efficiency and nothing else, right? So if you are not so much concerned about efficiency, you can just be using character throughout. But in advanced programs, it's advisable to explicitly state what the space you want to use. So let's go ahead and then print this, Shift B, and we have 72 again returned, and that is the ASCII value. and we have 4 here, and the 4 here is the size. Remember, we printed out the size of L3. So over here we have at least 32 bits. That means it's bigger than character 16. So 4 times 8. So that's basically what we mean. And now I want to illustrate something over here. Now some languages like Russian characters have bigger ASCII values than normal English characters. So let me go ahead and then use this as hello. So right now the character is character 32T. We want it to store hello, and we want a room of 8 bits, sorry, 4 bits, 4 bytes to be used. Now I'll create a second one, same character 32T, and in this case it's going to be L4, and we're storing in the Russian format for hello, which is here, which I looked up and copy, and we're pasting it in here, and then with a semicolon, don't forget that. And then what we want to do here is to copy this line. We're duplicating it. We ship this. Okay, so right now we are printing out L4 here, and then size of L4, right? So this is what we want. So we print the first 2 values will be for L3 and the size of L3, and the second 2 values will be for L4 and the size of L4. So let's go ahead and run this. And we have over here the size of hello. This is hello in ASCII values in English, and this is hello in Russian. And you can see that it's way bigger than the hello, the English format for hello. Over here it starts with 3, and I think it's in billions. Yeah, because this is million, and this is should be billion, right? So but this is just, you can see that this is far bigger than this one. Yeah, so for Russian characters and for other form of characters, they might be bigger than English characters, so you will want to create bigger space for them on the hard disks, right? So that's just the basic concept under these character types and these subsets under the fundamental data types, right? So I'll go ahead and comment out all of these, and then we continue with the integers, right? So now we have integer types as well, and we have signed integers and we have unsigned integers. And for signed integers, they are both positive and negative numbers. They allow you to store both positive and negative numbers. But for unsigned, you can only store positive integers. And we have already talked about integers. Integers are whole numbers. They can't be exponential and they can't be fractional. They can be negative, but they can't be decimated, right? So we want to illustrate this using an example. And so let's create a variable to store an integer. And over here I created one called signed short integer. Now we have always been using, if we want to create an integer, we just use the int keyword num1 is equal to 8, right? This is okay. Now what we are doing here is that we have used the keyword int, but now we are using the keyword signed short int. We are explicitly stating that we want to sign short int, we want to create a space of at least 16 bits for this particular variable. That is what we are saying. So I have a variable and I am telling you to create this amount of space for it. That's the basic concept of it. But over here, when you just use int num8, it's the same thing as signed int over here. Now the concept is that over here, I can eliminate all the signed, and then use character, and then use short int, and then use int, long, long int. The signed doesn't matter, but when you're defining with these ones, you have to explicitly state unsigned character, unsigned short int, and all of these. But this detail is not really necessary. You can explicitly state it signed short int. Let's just get the concept that we want to communicate. So over here, we are creating a variable called num1, called n1, sorry, and we are creating a space of not more than at least 16 bits for it. Now I want to print the size of this variable. So what I can do over here is, over here I wrote the size on a different line, but right now I want to input it on the same line. So what I can do is I can bring in two less than signs like this and then write whatever I want here. So it's going to be size of what? We are looking for the size of n1, right? And we have 7752, and you can see that they are joined. So what we can do right now is to put in space over here, and we will learn more about these escape characters in the future, but I just want to introduce one at this point in time for the sake of this video. So what I can do is I can add two more less than signs, and then with the character backslash and t, so you can note that is stored in single quotation marks because this is a character. We'll talk more about those ones in the future. And this is the tab. It simply creates a horizontal space between two things. So let's go ahead and print this and see what it outputs. Now we have 775 and 2. So now what we have here is, first we printed out n1, which is 775, and then the size of n1, which is 2. And 2 is this in bytes, so it's going to be 2 times 8, which is 16. So it has created at least 16 bits for this particular integer, right? So now let's go ahead and create a second one, but in this time we are using the signed integer. So we want to tell the computer that when we create one using the signed int, we want a space bigger than signed short int, but at least 16 bits. That's what we want to do. So we are creating this, and then we are giving it a name of num2, and we are putting in the same 775. Yeah, so the major concept here is to know the space. The concept, what I want to communicate is that we are creating different spaces for the same variable, and based on that you can know that this is more efficient than this, so that you know what kind of specific keyword to use. So we go ahead and then copy this, copy, and then we paste it down here, right? And we change this to num2, and then this to num2, right? So we run this and we see the same number displayed, which is what we stored, and then 4, and the 4 here is in bytes, remember that. And you can see that much room has been created for the same variable. And if the now you can see that this variable is small, and so you don't need to create much room for it that way. So what you can do is you can just use the sign short integer explicitly if you need that much efficiency, if you are so much meticulous on your program and all of that. So that is the major concept that we want to communicate. Okay, so let's just do the last example, which is signed long int, or let's use the long int rather. We want to call it n3, and we're storing the same value in there, right? And then let's paste what we had already copied, and then we change this to n3, and then this one as well, n3. We go ahead and run it, and we get 8 over here. Now the 8 is the storage space that was created for the same variable. So you can see that more space was created for the same variable. Now one other thing you need to note is that over here you can omit the words for the signed integers. You can omit the word signed, signed, signed. So I could have just deleted this and just referred to it as short int, and deleted this and just referred to as int, and deleted this and just referred to as long int. Let's run this and see the output, and we get the same output, right? So that's it. And you can see over here that this one we deleted a signed int. We just deleted a signed, and so it was left with int n2, and that's the usual one that we have always been using. And so that's signed int, and we always create a space of at least 16 bits for every of those variable that we use the int keyword for. Yeah, so this is what we've always been using. And the technical name for it is assigned integer, right? So I could have deleted this one as well and just left it long. So delete this one as well, and then delete this one as well. So we just have short n1, int n2, and long n3. Let's run this and see the output. And we get the same output as before. Now for the unsigned only store positive values. Now what you need to note is that for these ones, they have the same storage space as their signed counterparts. So unsigned character has the same space allocated for signed character. And let me just say something about this one. The signed character equates to a character over here. So they have the same space. It doesn't really matter. So unsigned character and signed character and just character, they have the same space. Yeah, so over here, unsigned short integer has the same storage space as a signed short integer, right? So same storage space is created for those ones. But now what you need to note here is that this particular one, when you use this keyword unsigned, it only allows you to store positive values. Now, this is what I mean. When I create a variable, let's say I'm using the unsigned int. Let me use unsigned int. Sorry. Right, so I'm creating a variable unsigned int and I'm calling it num n4. Let me just call it n4. And then I am putting in a 6 over there. And then I create signed int and I'm calling it num5 n5 and I'm equating it to, let's say, 6. Same thing. Now the unsigned integer, that's c, over here to c as well. Yeah, not smaller than short, at least 16 bits. So at least 16 bits is created for this one. Now what this one does is, for this particular one, you have 16 bits. So you have 16 bits full storage for positive numbers. But when you use signed integer, half of the space is used for the negative values. So over here, 16 bits, that means that 8 bits, 8 bits, 8 bits of storage used for negative values and 8 bits used for positives. So this is what it does. The signed one allows you to store both positive and negative values. And so half of the space is created for negative values and half of the space is allocated for positive values. But when you use the unsigned, you use the full 16 bits for your variable, for your positive value. So let's say you are creating a variable that is to store all positive values, within your program. You know that that particular variable can't be negative, it's always going to be positive. So you can explicitly use the unsigned integer keyword to ensure that all the space is used for that particular variable. If you use the signed counterpart, you have extra space allocated for half of the space allocated for negative values, but you will not be using it because your variable is never going to be negative. So you have created space that you will never be using. So if your variable is going to be positive, then you are advised to use the unsigned classes. And if it's going to be always positive and very large, then you can use the unsigned long integer so that you have extra room for that particular big variable, which is always going to be positive. So I hope this clarifies the unsigned and signed classes under the various under integers. I hope this really helped.